In this lesson, we're going to cover the first two applications of the normal distribution, which are just examples, but that are in the form of a word problem. We'll do example 3 and example 4, and then in the next lesson, we'll cover example 5. So example 3 says, the length of time it takes college students to find a parking spot in the library parking lot follows a normal distribution with a mean of 3 minutes and a standard deviation of 1 minute. Find the probability that a randomly selected college student will find a parking spot in the library parking lot in less than 2.5 minutes. So I'm going to keep stressing this for the rest of the semester, that every time you read a word problem, don't just try to get the answer. I want you to extract or highlight all the important pieces of information that are going to be useful, and then we'll go to the problem. So honestly, I don't even care about that last sentence right now where it says find the probability. I'm just going to focus on that first sentence. Ask yourself, all right, who or what are we studying? What's my population? Did we take a sample? Do we know what we're measuring? Do I have a mean? Do I have a standard deviation? Do I know shape? So these are the things I want you to ask yourself. So in this case, we're looking at a population of college students, and the variable of interest is how long it takes or time to find a parking spot in the library parking lot. So we know X is time. That's my variable, and we're in minutes. Now, we weren't given a data set of all the different times for every single student in this population that it takes to find a parking spot. However, we were given important pieces of information. The first one being is that time follows a normal distribution. So X is normal, or time is normal. So we're working with a normal random variable. So right away, you should be thinking bell-shaped curve, right? And we'll draw it in a second. But we also know the mean of the distribution is 3 minutes and the standard deviation is 1 minute. So let's write that down as well. So the mean is equal to 3 minutes. Notice I'm not putting a symbol because I want you to think about what symbol we're using. There's two possibilities, right? It's either going to be mu or X bar. So you have to ask yourself, okay, this mean of 3 minutes, is this for the whole population or is it for a sample? Now, there was no mention that a sample was taken, so we're assuming this is all college students. So we have to use the population mean, which is mu. Therefore, we're going to use sigma, which is the population standard deviation as well, and that's 1 minute. So what I would do is I would draw a picture. This is what time looks like, right? It's normally distributed, and the mean goes in the middle, and the mean is 3 minutes, right in the center. Now let's go to the problem. Now let's say, okay, what is the question asking for? So it says, find the probability that a randomly selected college student will find a parking spot in the library parking lot in less than 2.5 minutes. So I'm going to encourage you to write this sentence in English in math notation and statistical notation. So remember how we write probability that, right? So we want to find the probability that, or P of. Now, the time it takes to find a spot is going to be less than 2.5 minutes. And we already said we're using X as time, right? That's my random variable. So what is the probability that time to park is less than, and there's my inequality for less than 2.5. So this is what we're trying to solve for. And the other thing that we learned in the last couple of lessons was that area under the curve is equal to probability. And I'm looking for a probability, right? So if I could just locate this particular area under this normal curve and find the probability, I have my answer. So where is X less than 2.5? Well, 3 is in the middle, right? So the 2.5 is less than 3. So let's say here's X is 2.5. And we want to find the probability that the time it takes to park is less than 2.5. Anything less than 2.5 is going to be to the left on a number line, right? So we're looking for this area that I just shaded under the curve. So how do we do that? Well, now you know, right? We did other examples in the previous lessons. We could use the normal table to find the area under the normal curve, or we could use the calculator. I'm going to use the calculator. Actually, you know what? One more time, I'll do it both ways. Let's use the table and then we'll use the calculator. But in order to use the table, we need a z-score, right? We can only look up z-scores on the table. So we're going to have to convert this 2.5, because that's an x value, right? We have to convert it to a z-score. So let's do z-score over here. So remember, z-score is equal to data value minus the mean over the standard deviation. So z in this case is going to be 2.5 minus the mean, which is 3. And we have to divide that by 1, which is a standard deviation. So we're taking 2.5, we're subtracting 3, and we're going to get negative 0.5, right? Because we're dividing by 1. So my z-score that corresponds to a raw score of x equals 2.5 is going to be negative 0.5, which makes sense, right? Because if one standard deviation is 1 minute, and the mean is 3 minutes, 2.5 is only a half a minute away from 3, right? But in the negative direction. So we would look up a z-score, and let me just pull up. I don't have my table open. Let me just get my normal table. Okay, so we're going to look up a z-score of negative 0.5. So here's negative 0.5, and then we have a 0 in the 100 spot, and that's going to be 0.3085. So this area right here is going to be equal to 0.3085, and that's going to be the answer to our probability question. So that's the probability that a college student's going to find a parking spot in less than 2.5 minutes. They have about a 30.85% chance of taking that long, less than 2.5 minutes. Now, the other way we could do this is the calculator, right? We just need lower, upper, mean, standard deviation. So since we're shading from the left, right, the lower bound is going to be negative E99. And then the upper bound could either be your raw score or your z-score, whichever one you feel like using. Honestly, it doesn't matter. I'll use the raw score. So here's my calculator. So we're going to pull up normal CDF. Remember, we press second and then the Varus key. Option 2 is normal CDF. My lower is negative E99 because we're coming in from the left. My upper, where the shading stops, is 2.5. Now, since 2.5 is the raw score, it's the X value, I have to use the mean and the standard deviation of the times of the data set. So the mean is 3 and the standard deviation is 1. If you want to use the z-score of negative 0.5 as the upper bound, that's totally fine. You would just have to use 0 and 1 for the mean and the standard deviation. That's all. So we're going to paste. And we get the same answer, right? 0.3085. So let's do one more. So example 4 says a physical fitness association is including the mile run in its secondary school fitness test. The time for this event for boys in secondary school is known to possess a normal distribution with a mean of 440 seconds and a standard deviation of 60 seconds. Find the probability that a randomly selected boy in secondary school will take longer than 302 seconds to run the mile. So let's do the same thing that we did in the previous example. Do not even care about the question. That last sentence where it says find, I don't care about it. You have to understand, what you're reading. What is the problem not even necessarily what is it asking for, but who is involved? What's the group that we're studying? What's the variable of interest? What do I know about this variable? So we're looking at a population of secondary school boys or boys in secondary school. And what we're measuring about them is the time it takes them to run a mile. So that's what X is in this case. Similar to the example above, X is time, but this time it's in seconds. We're measuring time in seconds. And there's no mention of a sample. So we're assuming this is the population of all secondary school boys, whatever this particular school is. So we know the mean, we know the standard deviation, and we also know that time possesses a normal distribution. And the mean is 440 seconds and the standard deviation is 60 seconds. So let's write that down. So X is normal. The mean, since we're assuming it's the population, is 440 seconds, and the standard deviation is 60 seconds. And sketch your picture, right? Normal distribution with a mean of 440 in the center. Now let's go to the question. So the question says, find the probability that a randomly selected boy in secondary school will take longer than 302 seconds to run the mile. So let's take that sentence and put it into math notation. So we want to find the probability that the time, which is X, it takes a boy to run the mile, is longer than means greater than 302 seconds. So greater than 302. And that's what we want to find. And again, remember, probability is equal to the area under this normal curve. So we just have to locate the area and then we can find the probability. So where are the times that are longer, greater than 302 seconds? Well, 440 is in the middle, right? 302 is less than that if this were a number line. So X equals 302 is going to go to the left. And we want greater than or longer than. So we're going to shade the area to the right. So this is the area that I'm interested in finding, and that's going to be equal to the probability. And I'm going to do the calculator only. So going forward now, anytime we need to find an area under the normal curve, I'm going to go right to the calculator. So we use normal CDF and we need 4 things: lower, upper, mean, standard deviation. So the lower bound in this case, in other words, where does the shading start from the left? It starts at 302, so that's my upper. And technically, we're shading to the right indefinitely. So my upper is positive infinity, or E99. And since I'm going to use my raw score as the lower value, I need to use the mean and the standard deviation of my distribution. So now we're ready to plug in to the calculator. So we said the lower is going to be 302, the upper is E99, the mean is 440, and the standard deviation is going to be 60. So let's pull up normal CDF. So second and then the varus key. It's option 2. So my lower is 302. The upper is E99. The mean is 440. And the standard deviation is 60. We paste and then hit enter. And if we go 4 places, we get about 0.9893. So this shaded area is approximately 0.9893, and that's going to be the answer to the probability question. So there's about a 98.93% chance that it's going to take a secondary school boy more than 302 seconds to run the mile. So we'll end this lesson here. And in the next lesson, we'll do one more application question, example 5, and it has 3 parts to it.